Welcome back to the quiet space of knowledge before sleep. Tonight, as the city lights fade into the distance and the hurried pace of a long day finally settles, I invite you to join me on a journey not with your feet, but with your mind. Let your shoulders relax, soften the muscles in your face, and allow your breath to flow as naturally as possible. Together, we will leave the ground, float through the soft, fluffy clouds, and pass beyond the delicate atmosphere that envelops the Earth, to stand at the threshold of the vast cosmos. When you look up at the sky on a truly clear night, you'll see thousands of tiny, twinkling specks of light, like whispers from a distant past. Have you ever wondered, amidst all those brilliant celestial bodies, why the encompassing space is such a deep, profound black, if we know there are billions, even trillions of stars out there, each one a giant, blazing ball of fire? Shouldn't the sky be as bright as day? This isn't just a simple question. It is one of the greatest problems in the history of astronomy, a paradox that has puzzled the greatest minds for centuries. Imagine you're standing in the middle of a dense, infinite forest. If that forest had enough trees, then no matter which direction you looked, your gaze would land on a tree trunk. There would be no empty space, allowing you to see beyond the forest. The universe should be the same. If it contains an infinite number of stars stretching on forever, then at every single point in the sky we look towards, there should be a star. The night sky ought to be blindingly bright, more brilliant than the midday sun. And yet, the reality is a silent, ink-black night. This contradiction leads us on a journey to discover the nature of space, time, and the very beginning of everything. In this opening chapter, we will begin to uncover the first clues to the answer. The dark space you see is not actually empty. It holds secrets about how far and how fast light travels. You see, light doesn't appear instantaneously, even though it's the fastest thing in the universe, moving at about 300,000 kilometers per second. On the grand scale of the cosmos, that speed becomes remarkably small. For light to travel from the moon to our eyes, it takes about 1.3 seconds. To get here from the sun, it needs about 8 minutes and 20 seconds. And to reach us from the most distant stars we can see with NASA's Hubble telescope, light has had to journey for billions of years. This means that when you look into the dark space between the stars, you might be looking at places where the light from the stars there simply hasn't had time to reach Earth yet. Our universe has a finite age. It hasn't existed forever since the beginning of time. According to the latest findings, the universe is about 13.8 billion years old. Therefore, we can only see the light from objects that are within the distance that light could have traveled in that time. What lies beyond that horizon is, for now, just a mysterious shadow. The night is not an absence of light, but rather a testament to the fact that our universe had a beginning. It tells us that space is expanding and everything is changing. That darkness brings us a sense of peace, a necessary shelter for life to rest and regenerate. Imagine the night as a giant velvet blanket, wrapping our small blue planet, protecting us from the terrifying heat of the billions of suns out there. In the chapters to come, we will peel back each layer of mystery. We will learn about a man named Heinrich Olbers, who bravely posed the question of the universe's darkness in the 19th century. We will discover how galaxies are moving away from each other at staggering speeds, causing their light to be stretched and become invisible to the naked eye. And we will also listen to the echo of the dawn of time, the residual light from the Big Bang that still lingers somewhere in that darkness. But for now, you don't need to think too much about the numbers or the dry theories. Simply feel the silence that envelops the room. Feel the vastness of the space out there and the warmth of the bed you're lying in. The dark universe is not meant to frighten us, but to remind us of the beauty of the unknown and of the preciousness of the little light we do have. The night is a gift. It allows us to dream distant dreams, to transport our souls to star-filled realms that our eyes have never seen. Let your mind drift among the milky arms of the galaxy, gliding past vibrant nebulas of purple, blue, and pink, hiding behind the darkness. You are a part of this universe, a tiny but incredibly special part. Imagine you are holding a handful of fine sand. Each tiny grain represents a brilliant star. Did you know that the number of stars in the universe is greater than all the grains of sand on all the beaches of our planet combined? It's a colossal number that the human mind can barely comprehend. According to calculations from the most advanced telescopes, like the James Webb, there are about 2 trillion galaxies in the observable universe, and each of those galaxies contains anywhere from tens of billions to thousands of billions of stars. If we were to write that number out, it would be a 1 followed by 24 zeros, an impossibly long number symbolizing an endless ocean of light. Each of those stars is a massive nuclear reactor, releasing tremendous energy into space every second of every minute. There are stars thousands of times larger than our sun, emitting light so brilliant it could illuminate a vast region of space, billions upon billions of kilometers wide. So, with so many light sources, why doesn't the universe become a blazing sea of light? Try to imagine yourself standing in a room with millions of extremely powerful spotlights hanging from the ceiling. Just a few of them would be enough to dazzle you, let alone millions of trillions. And yet, the reality is that between these stars are empty voids that are almost terrifyingly vast. To understand this, we need to look at distance. In the universe, distance isn't measured in ordinary meters or kilometers, because those numbers would become too small. Scientists use the unit of a light year. The distance light travels in 1 year. 1 light year is equivalent to about 9,460 billion kilometers. The star closest to our solar system, Proxima Centauri, is still more than 4 light years away. That's nearly 40 trillion kilometers. And that's just our closest stellar neighbor. Other stars are millions, even billions of times farther away. This sparseness is a peculiar feature of the universe. Although there are trillions upon trillions of stars, because space is so immeasurably vast, their actual density is very low. Imagine if each star were an orange. On average, each orange would be thousands of kilometers apart. It is precisely because of these immense distances that the light from faraway stars has greatly diminished in intensity by the time it reaches our eyes. They are merely faint, fragile points of light amidst a vast sea of black. However, the argument of distance alone is not enough to fully explain this paradox, because, as we mentioned in the previous chapter, if the universe were infinite, then no matter how far away the stars are, their numbers should be sufficient to fill every gap in the sky. If you were to look at any random dark spot in the heavens, theoretically, if you looked deep enough and far enough, you would eventually hit the surface of some star. But why do our eyes see only a deep, profound black? The answer lies in the miracle of the structure of space itself. The universe is not a static box filled with stars. It is a living, moving entity that is constantly expanding. Galaxies are not stationary. They are drifting away from each other, and it is this very motion that changes the nature of the light we see. Right now, as you lie here listening to these words, imagine yourself as a tiny speck of dust floating in the river of the Milky Way. All around you are dark, cold voids, yet they possess a serene and beautiful tranquility. The night is not an enemy of light. It is the very canvas that allows light to reveal itself. Without that profound darkness, we would never see the sparkling beauty of the constellations, never witness the Milky Way stretching across the sky like a soft ribbon of silk. The darkness in the universe is like the moments of silence in a symphony. If a piece of music consisted only of loud, dazzling, and relentless high notes, our ears would soon grow tired. It is the silences, the gentle low notes that create depth and move the soul. The vast night out there is the same. It allows the universe to rest, and it allows us tiny beings on a blue planet to have a quiet space to reflect and to dream. The deeper we delve into this mystery, the more we realize that this darkness is not empty. It contains information about the history of everything that has ever been. It tells us about places where matter had not yet formed, or places where light has been swallowed by powerful, invisible forces. Why is that? Those points of light, though as numerous as grains of sand, are still swallowed by the pitch-black void. This leads us to an obvious yet astonishing truth. The universe is mostly empty space. If you were to take all the matter in the universe, including all the stars, planets, and dust, and compress it into one place, it would occupy only an infinitesimally small fraction of the empty space that surrounds it. Imagine a dark night where you light a small candle in the middle of a field thousands of acres wide. The candle's light can only illuminate a very small area around it. People standing far in the distance would only see a faint pinpoint of light, while the rest of the entire field remains plunged into darkness. The universe is just like that, but on a scale that is billions upon billions of times larger. The distances between stars are so immense that their light isn't enough to fill the darkness of the void. Let's drift slowly into the tranquility of the 19th century, an era when people began to look up at the sky with more sophisticated telescopes, yet their minds were still filled with fundamental questions about the nature of the universe. In this chapter, we will meet a doctor, a German astronomer named Heinrich Olbers. He was not only a lover of the sky, but also the man who bravely articulated a contradiction that the world would later name after him, Olbers Paradox. In the year 1823, Heinrich Olbers posed a question so simple, yet so powerful. He hypothesized that if the universe were static, infinite, and contained an infinite number of stars distributed evenly everywhere, then the night sky could not possibly be dark. According to his reasoning, no matter which direction you looked, your line of sight would eventually have to land on the brilliant surface of a star. To visualize this better, imagine you are in a vast forest, where the trees grow close together and stretch on forever in every direction. No matter where you turn your head, your view will be blocked by a tree trunk. You cannot see the empty space beyond the forest because the trees completely obscure your vision. If the universe were an infinite forest of stars, then the night sky should be as dazzlingly bright as the surface of the sun. The light from trillions upon trillions of stars would combine, turning night into day, and its heat would even incinerate every planet. And yet, the reality is that we are lying here in a gentle and cool night. This means that one of our assumptions about the universe must be wrong. Either the universe is not infinite, or the stars are not evenly distributed, or the universe is not static at all. Olbers spent a great deal of time pondering this. Initially, he and many scientists of his time thought that perhaps giant clouds of dust in space were obscuring the light from distant stars. However, the laws of thermodynamics later showed that if the dust blocked the light for a long enough time, the dust itself would heat up and begin to glow. Therefore, the dust theory could not be the final answer. This paradox was like a wall separating humanity from a true understanding of the origin of all things. It forced us to accept a truth that was shocking at the time. The universe has not always existed as we see it. It must have had a beginning. Imagine you are watching a fireworks display from very far away. When a firework explodes, its light doesn't reach your eyes instantly. If the show had only just begun a few seconds ago, you would only see the closest explosions. For the fireworks launched farther away, their light is still on its way, not yet having arrived before your eyes. This is part of the solution that modern scientists have found to explain Olbers' paradox. Now, Feel your breath, steady and rhythmic, like the slow pulse of time in the vastness of space. The blackness you see when you look up is actually evidence that we live in a universe with a finite age. The light from stars that are too far away has simply not had enough time to travel to Earth since the universe was formed. The darkness is the silent pause of light rays still journeying through the endless night. Olbers Paradox is not just a dry scientific problem. It's a lesson in how we perceive the world. Sometimes, what we don't see is more important than what we do see. The blackness of the sky is a message from the dawn of creation, telling us that our universe has a history, a process of birth, and is constantly changing. Let the image of Dr. Olbers and his question fade from your mind. You don't need to find the answer right away. Just remember that even the darkness has a name and a reason for its existence. It protects us from the blinding glare of infinity, creating a gentle space where all things can rest. The silence of the night that we are feeling holds a secret about age. For thousands of years, people believed that the universe was static, unchanging, and had existed forever since an infinite past. If that belief were true, Olbers' paradox would never have a solution, and the sky would have to be blazing bright. But modern science has proven something entirely different. Our universe has a birthday. The concept of time in the universe is closely tied to light. As we know, light travels at a speed of about 300,000 kilometers per second. This is the fastest speed in nature. But compared to the enormous scale of space, it's like the pace of a slow walker. When we look at a star that is 10 light years away from Earth, we are not seeing the star as it is in the present. We are seeing its image from 10 years ago. It took exactly 10 years for that light to journey through the cold void to reach your retinas. This leads to a profound consequence. The farther we look into space, the further we look back into the past. And because the universe was formed only about 13.8 billion years ago, there is a limit to what we can see. The light from stars or galaxies located farther than 13.8 billion light-years away simply has not had enough time to reach us. They are like guests invited to a party of light who are still on their way and have not yet appeared. The darkness you see between the stars is precisely the space that light has not yet had time to fill. If the universe had existed for eternity, the light from every farthest corner would have had more than enough time to fill the sky. But because the universe has a beginning, our vision is limited by a time horizon. Beyond that horizon is darkness, not because there is nothing there, but because the light information from there is still on its long journey. Imagine a colossal theater that has just turned on its lights. The audience in the front rows will see the light immediately, but those in the very back, in a space billions of kilometers wide, will have to wait a very long time to see the first rays. Our universe is in a similar state. It is still too young for the entire sky to be brilliantly lit. The darkness is the most authentic proof that the universe had a starting point, a moment of birth that we call the Big Bang. The finiteness of time has resolved a large part of the paradox that Heinrich Olbers posed. It shows that we are not surrounded by an infinite sea of stars present all at once. Instead, we can only see a small part of the universe, a part that is close enough and young enough for its light to have reached us here. The rest of the universe remains hidden in darkness, waiting for time to pass to be revealed. As you relax into the peace of the dark night, think about how you are looking into the history of all things. Each black space between the stars is an unturned page, an ancient region of space from which light is still diligently traveling. That blackness is not emptiness, but the awaiting of light. It reminds us that everything needs time to mature, to spread, and to be understood. To better understand why the night prevails, we need to travel back in time to the very first moment of everything, the Big Bang. This was the moment when space, time, and all matter came into existence. Before this moment, as far as we understand, there was no before, nor was there darkness or light. About 13.8 billion years ago, the entire universe we see today was contained in a point smaller than an atom, yet it possessed a terrifyingly high level of energy and temperature. When this point began to expand, it created a blinding stream of light, more brilliant than anything we can imagine. For the first few 100,000 years, the universe was a dense, hot fireball. At that time, light could not travel freely because it constantly collided with dense particles of matter. The universe then was like a brilliant but opaque fog of light. However, as the universe continued to expand and cool, a miraculous event occurred after about 380,000 years. Atoms began to form, space became transparent, and for the first time, light was released to travel everywhere. These are the most ancient rays of light in the universe. If the night sky were truly filled with light from this primordial era, then we should be seeing a brilliantly glowing sky in every direction. So, why do we see blackness now? The answer lies in the expansion of space. As the universe expands, it doesn't just push galaxies away from each other, it also stretches the very wavelengths of light traveling through it. Imagine drawing a wave on a rubber band. When you stretch the rubber band, the wave gets longer. The same thing happens to light. The brilliant, high-energy light rays from the dawn of time have been stretched over billions of years of travel, so much so that they are no longer visible light that the human eye can see. Those light rays have now turned into radio waves and microwave radiation, things that our eyes perceive only as deep blackness. If humans had eyes that could see radio waves, we would see that the night sky is not dark at all, but that it glows uniformly bright with the aftershock of the Big Bang. But due to our biological limits, we can only see a very small part of the spectrum, and the rest appears to us as a silent night. The beginning of the universe created light, but it is its expansion and its age that have kept the night sky a deep black. This helps to balance the temperature on planets, allowing life to sprout without being scorched by thermal radiation from all directions. The darkness you see is a protective veil, the result of a grand evolutionary process of space over billions of years. As you lie here, feel the greatness of the journey that these light rays have taken. From a hot, dense point, the universe has expanded into the vast space it is today. The blackness of night is not an end, but the trace of a brilliant beginning that has receded far into the past. It gives us a quiet moment to breathe, to ponder our place in the endless flow of time. The darkness of the universe is a reminder that even the most brilliant light will eventually soften, giving way to tranquility and peace. That is the law of nature, a gentle rhythm that brings all things into a state of rest. Let your mind settle with the blackness of the sky, feeling the reassurance of knowing you are enveloped by such a long and magnificent history. Everything around you right now, from the air you breathe to the distant stars, shares a common origin from that single moment. We are stardust, floating in a universe that has cleverly arranged the darkness so that we can see the light. Just let yourself sink into this stillness, where time and space seem to stand still, preparing for new discoveries about the limits of vision in the chapters to come. As we delve deeper into the night, there is an important concept we need to understand to fully decode the blackness of the universe, and that is the observable universe. Imagine you are standing at the center of a giant circle. No matter how far you can see, you can only see what lies within the range that light has had time to travel since the beginning of everything. This is an insurmountable physical limit, creating a sphere of knowledge that surrounds us. The radius of this sphere is now calculated to be about 46 billion light years. Converted to kilometers, that's a colossal number, an immense figure that's difficult to comprehend. Every star, every galaxy that lies beyond this boundary is completely hidden from our view. not because they don't exist, but because their light is like a messenger running tirelessly on an endless road, who has not yet reached our doorstep. It is because of this limit that the forest of stars Heinrich Olbers once imagined actually has a border. It is not an endless forest with a canopy of light that covers every gap. Instead, it is more like a garden with a clear boundary. Beyond that boundary, there is only enveloping darkness. It is the darkness of the unknown, the darkness of regions of space from which information remains a mystery. When you look up at the black spaces between the constellations, you might be looking through the gaps of the observable universe into the void that lies beyond the limits of time. This brings a strange and tranquil feeling. You are standing at the boundary of what can be known and what can never be known. That darkness is not cold. It is a reminder that we humans, however small, are living in the most brilliant part of space. The limit of our vision is also a natural filter. If our eyes could see every star in an infinite universe, we would be scorched by the light energy. The darkness protects our eyes, protects our sleep, and keeps the Earth in a perfect temperature balance. Feel that safety. Feel that the universe has limited itself to create a gentle environment for us to exist. Take a slow, steady breath and let your mind drift with the expansion of space. One of the most important reasons the sky isn't blazing with light is that our universe is not static. In the 1920s, the astronomer Edwin Hubble discovered an astonishing truth. Galaxies are moving away from us, and the farther away they are, the faster they are receding. Imagine space as a loaf of raisin bread baking in the oven. As the dough expands, the distance between the raisins grows larger. The galaxies are those raisins. As the space between galaxies stretches, it also stretches the rays of light traveling through it. This phenomenon is called redshift. When a light source moves away from you at an extremely high speed, its wavelength gets stretched out. In the spectrum of colors that humans can see, red has the longest wavelength. When light is stretched beyond the threshold of red, it shifts into infrared, and then into radio waves. At this point, the human eye is no longer able to perceive them. The stars at the edge of the observable universe are moving away from us so fast that their light is drained of energy. What was once brilliant white light, after a long journey of being stretched, is now just faint heat waves that our eyes see only as deep black. Without this expansion, the sky would probably be much brighter. But it is the tireless motion of space that has skillfully turned light into darkness. The expansion of the universe is like a slow and magnificent breath. It pushes back boundaries, creates more space, and softens the harsh streams of light. The night is the result of this ceaseless motion. It shows that our universe is alive, growing, and changing every second. Let the thought of this expansion soothe your soul. Everything is receding, creating an immense space for you to dream freely. Nothing is fixed, nothing is confined. Among those distant galaxies, darkness is being woven by the movement of space itself. It is a silent but incredibly majestic dance, a rhythm that guides you into a state of absolute relaxation. As we end this chapter, we understand that darkness is not a static state, but the result of a journey that transforms light. Light is stretched, pushed back, making way for a dark but peaceful night. Just let yourself drift along with that expanding flow. Feel the gentleness of each breath and prepare for the next discoveries about the hidden colors in the following chapter. In the stillness of the night, our eyes often believe that what cannot be seen does not exist. But the universe is a master of concealment. To understand why the sky is dark, we need to grasp the fact that light consists of more than just the colors of the rainbow we typically see. Light is a vast spectrum of energy, and the human eye can only capture an extremely tiny portion of it. Much like hearing only a few notes in a colossal symphony, imagine light as waves on a lake. There are short, rapid waves that carry a lot of energy, and there are long, slow waves that carry less. Violet and blue are the short waves, while red are the longer waves. As light from distant stars journeys through expanding space, these waves are stretched out. The redshift phenomenon we mentioned in the previous chapter is the key here. As space expands, it stretches the wavelength of light, causing the color of stars to gradually shift from blue to yellow, and then from yellow to red. But the magic doesn't stop there. When the distance between us and the galaxies becomes too great, the light is stretched so much that it moves beyond the red region visible to the human eye. It enters the infrared range and then the radio wave range. At this point, even though those stars are still burning brightly, to our mortal eyes, they have completely vanished into nothingness. The dark sky you are observing is actually a canvas full of color, but they are invisible colors to human biology. If you had eyes that could see infrared rays, the night sky would no longer be a silent black. Instead, you would see space ablaze with the warmth of distant galaxies. You would see radiant dust clouds and stars hidden in the darkness. But it is precisely because we cannot see these long wavelengths that the universe appears so peaceful and gentle. The blackness of night is a natural filter for our vision. It allows us to focus on what is closest, on the stars within our own Milky Way, instead of being overwhelmed by the trillions upon trillions of light sources pouring in from everywhere. Feel this gentleness in your mind. The darkness is not emptiness. It is an ocean filled with mysterious colors flowing slowly. These long wavelengths are like the softest whispers of the universe. They are everywhere, but do not disturb your rest. Now, we will listen to one of the most ancient sounds together, or rather, look at the oldest light remaining in the universe. This is the final and most powerful answer to the question of why the night sky is black. As mentioned, about 380,000 years after the Big Bang, the universe became transparent, and the brilliant primordial light began its great journey. That light was once thousands of degrees hot and blazed in every corner. Over the past 13.8 billion years, as space has expanded relentlessly, that dazzling light has been stretched thousands of times over. From rays of immense energy, they gradually cooled and became extremely short microwaves. Scientists call this the cosmic microwave background radiation. This is the excess light that fills the entire sky. As predicted by Olbers Paradox, however, because it has been stretched so much, its temperature is now only about -270 degrees Celsius, just slightly above absolute zero. This light is present in every direction of the sky. If you turn on an old television with no signal, a small fraction of the white static on the screen is your TV picking up this microwave background radiation. The universe is, in fact, absolutely radiant, with not a single crevice devoid of light. But because its wavelength is too long and its energy is too low, the human eye perceives only absolute black. Imagine you are lying in a sea of the gentlest light imaginable. It doesn't dazzle you, it brings no heat. It simply exists as a silent witness to the beginning of time. The darkness surrounding you is the current form of that primordial splendor. It has been shaped, stretched, and cooled by time to become a soft velvet blanket, lulling every living creature to sleep. As you breathe steadily in the night, know that you are enveloped by this most ancient light. It is the echo of the past, the foundation of all things. The sky is not black because it lacks light, but because it contains a light that has become incredibly gentle. This truth brings a strange sense of peace. We are never truly alone in the dark, for the entire universe is always brilliant in its own way, a silent and forgiving way. Let the idea of this sea of microwave light ease your mind. Every empty space is filled with information. Every shadow is a message from the past. You are resting in the arms of cosmic history, where the greatest things have become the gentlest. Just let yourself drift, slowly, deeply, into this wonderful silence. In our journey to find the answer to the universe's darkness, we must mention the silent gatekeepers of space. These are the giant clouds of dust and gas, also known as nebulae. If you imagine space as a vast ocean, then these dust clouds are like dense fog banks, drifting lazily, obscuring our view into the deepest regions of the Milky Way. Cosmic dust is not like the dust in your room. It is made of tiny particles of elements like carbon, silicates, and sometimes ice. They are the remnants of dead stars or the raw material for forming new ones. However, their role in creating the blackness of the sky is crucial. When light from a distant star travels to Earth, it must pass through thousands of light years of empty space. Along the way, if it encounters one of these dust clouds, the light will be absorbed or scattered in other directions. Imagine you are standing in a brightly lit city on a foggy night. You know there are millions of lights out there, but all you see is a hazy glow and vast stretches of darkness. The fog has swallowed the light before it could reach your eyes. In the universe, dust clouds do the same thing. They create enormous dark regions in the sky, where the naked eye cannot see through to the billions of stars burning behind them. There are regions of space called dark nebulae, where the dust density is so thick that it completely blocks visible light. When we look at them, we see only a bottomless black patch, like a hole in the velvet curtain of the sky. But in reality, these are stellar nurseries, where new stars are quietly taking shape under the protection of darkness. The presence of dust helps us understand that sometimes darkness is not due to a lack of light, but because the light has been cleverly concealed. The existence of cosmic dust gives us a sense of nature's discretion and privacy. Not everything brilliant needs to be displayed. The darkness from these dust clouds is like a curtain, hiding the new life that is about to be born. Let your mind settle. Feel the protection of these great curtains. They maintain a necessary mystery in the universe, keeping us ever eager to explore and discover. The universe is not a static picture, and stars are not lamps that burn forever. To understand why the night is dark, we must accept a sobering truth. Stars have lifespans. They are born, they shine, and then their time comes to fade away. Each time a star dies, a part of the universe's light disappears, giving way to the encroaching darkness. A star like our Sun has a lifespan of about 10 billion years. It is currently halfway through its life. When a star exhausts the nuclear fuel in its core, it begins a slow process of transformation. Small stars will gradually cool and become cold, black dwarfs, floating silently in space. More massive stars will end their lives in a glorious supernova explosion before collapsing into a neutron star or a black hole. On a timescale of billions of years, generations of stars are born and then die in succession. Olbers Paradox assumed that stars exist forever, but that is not the case. If we were to add up all the light from every star that has ever existed, the number would still be finite, because not all stars shine at the same time. Some stars died out long before others were even formed. The life and death of stars create a rhythm for the universe. Darkness is where old matter returns after having dedicated all its light to space. It is also the repository of materials for the next generations of suns. Imagine each star is a candle in a massive room. The candles are not lit all at once. As one is lit, another has already flickered out. As a result, the room can never be as bright as day, but always maintains a shimmering, hazy glow amidst the patches of darkness. The death of stars reminds us of the value of finiteness. It is because light is not eternal that every ray that reaches our eyes becomes incredibly precious. The darkness you see is the repose of stars after billions of years of tireless shining. It is a peaceful end, yielding the stage to new things that are about to unfold. As you lie here, feel the slow pulse of the lives of the stars. You are living in a moment in time where stars are lighting up the world for you to see. The blackness of the sky is proof of a universe in constant reincarnation, where light and darkness are always transforming into one another. Let this understanding bring you to a state of stillness, letting go of worries to merge with the endless flow of time and space. To understand the night more deeply, we need the help of those tireless eyes floating out there in space. For thousands of years, humans could only observe the darkness with the naked eye, which is easily deceived by atmospheric light and biological limitations. But everything changed when we placed great telescopes into orbit. And the first name that must be mentioned is Hubble. The Hubble Space Telescope, a joint mission between NASA and the ESA, has been working tirelessly in space for over 30 years. It is at an altitude of about 547 kilometers above the ground, where there is no thick layer of air to distort the view. When Hubble pointed its lens at a region of space we thought was completely dark and empty, it revealed a truth that upended all conventional thinking. In 1995, scientists had Hubble gaze into a tiny, darkest patch of the sky, where no visible stars could be seen. After 10 days of collecting the faintest particles of light, the resulting image astonished the world. In that region of space, as small as a grain of sand held at arm's length against the sky, there were over 3,000 galaxies. Each galaxy, in turn, contains hundreds of billions of stars. Điều này cho chúng ta biết rằng bóng tối mà ta thấy thực chất chỉ là một bức màn che được tạo ra bởi khoảng cách. Những thiên hà đó cách chúng ta hàng tỷ năm ánh sáng, và khi ánh sáng của chúng đến được đây, nó đã trở nên vô cùng yếu ớt, giống như một lời thì thầm nhẹ nhàng giữa cơn bão. Hubble đã dạy chúng ta rằng, với đủ sự kiên nhẫn và những công cụ đủ sắc bén, bóng tối sẽ bắt đầu nở thành ánh sáng rực rỡ của quá khứ. Sự tồn tại của những chiếc kính thiên văn này giúp chúng ta nhận ra rằng bóng tối là một khái niệm tương đối, nó là ranh giới giữa những gì công nghệ hiện tại của chúng ta có thể chạm tới và những gì vẫn còn ẩn giấu trong bí mật. Hãy tưởng tượng tâm trí của bạn cũng giống như một chiếc kính thiên văn. Khi bạn trở nên tĩnh lặng và tập trung, bạn bắt đầu nhìn thấy những điều mà bạn sẽ không bao giờ nhận ra trong sự ồn ào của cuộc sống hàng ngày. Bóng tối không còn là một sự trống rỗng đáng sợ, mà là một kho lưu trữ khổng lồ của ánh sáng đang chờ được giải mã. Nếu Hubble đã mở ra một cánh cửa cho chúng ta nhìn vào quá khứ bằng ánh sáng khả kiến, thì kính thiên văn không gian James Webb chính là bước nhảy vọt vĩ đại tiếp theo, chinh phục những góc tối nhất của vũ trụ. Được phóng lên vào cuối năm 2021, James Webb không nhìn thế giới bằng thứ ánh sáng mà mắt người có thể thấy. Thay vào đó, nó nhìn bằng ánh sáng hồng ngoại, thứ bức xạ nhiệt mà chúng ta đã đề cập khi thảo luận về sự giãn nở của không gian. Vậy tại sao chúng ta cần nhìn bằng tia hồng ngoại để hiểu về bóng tối? Như bạn đã biết, sự giãn nở của vũ trụ đã kéo giãn ánh sáng từ những ngôi sao cổ xưa nhất, khiến nó dịch chuyển từ ánh sáng khả kiến sang màu đỏ, và cuối cùng chuyển hoàn toàn sang tia hồng ngoại. James Webb được thiết kế với một tấm gương mạ vàng khổng lồ, có khả năng thu thập những sóng nhiệt cực kỳ yếu ớt này từ khoảng cách hàng nghìn tỷ km. Ngoài ra, tia hồng ngoại còn có một khả năng kỳ diệu. Nó có thể nhìn xuyên qua những đám mây bụi dày đặc mà chúng ta đã tìm hiểu ở chương 10. Những vùng không gian từng đen kịt đối với các kính thiên văn cũ, giờ đây lại hiện ra trước mắt James Webb, tiết lộ đầy đủ chi tiết về các ngôi sao đang hình thành và những thiên hà sơ khai nhất từ 13 tỷ năm trước. James Webb đang giúp chúng ta nhìn xuyên qua bức màn nhung của đêm để chạm vào những ánh sáng đầu tiên của vũ trụ. Khi bạn nằm đây, hãy hình dung kính thiên văn James Webb đang ở cách trái đất khoảng 1.500.000 km, trôi nổi và làm việc trong cái lạnh tuyệt đối của không gian. Nó đang không mệt mỏi quét qua bóng tối, sẵn sàng kể cho chúng ta nghe câu chuyện về nguồn gốc của chính mình. Những hình ảnh hồng ngoại rực rỡ mà nó gửi về là bằng chứng cho thấy bóng tối không phải là một bức tường, mà là một tấm gương phản chiếu giới hạn của các giác quan của chúng ta. Sự hiện diện của James Webb nhắc nhở chúng ta rằng Sự thật luôn ẩn giấu ngay trước mắt. Chỉ cần chúng ta thay đổi cách nhìn, bóng tối bao quanh hành tinh của chúng ta chứa đựng hơi ấm của hàng nghìn tỷ mặt trời mà chúng ta chưa từng biết đến sự tồn tại của chúng. Hãy để ý tưởng về cuộc săn tìm ánh sáng trong bóng tối này lấp đầy bạn với cảm giác vừa hứng khởi, vừa bình yên. Bạn đang sống trong một kỷ nguyên mà bóng tối đang dần dần tiết lộ những bí mật của nó. Khi chương này kết thúc, chúng ta biết rằng nhờ có những con mắt vĩ đại trên bầu trời, màn đêm không còn là một điều hoàn toàn bí ẩn nữa. Nó là một câu đố đang dần được giải đáp. Một bức tranh đang được tô điểm bằng những nét vẽ rực rỡ của ánh sáng hồng ngoại. Hãy cảm nhận một cảm giác bình yên khi biết rằng ngay cả trong những khoảng không tăm tối nhất, ánh sáng vẫn luôn hiện diện dưới hình thức này hay hình thức khác. Bây giờ, khi chúng ta đã đi được hơn nửa chặng đường trong hành trình khám phá màn đêm, có một thế lực bí ẩn mà chúng ta phải đối mặt. Nó không phải là ánh sáng, cũng không phải là vật chất, nhưng nó chiếm tới khoảng 68% toàn bộ vũ trụ. Các nhà khoa học gọi nó bằng một cái tên bí ẩn: năng lượng tối. Nếu bóng tối mà chúng ta thấy là sự vắng mặt của ánh sáng, thì năng lượng tối chính là thứ đang tích cực tạo ra nhiều bóng tối hơn mỗi giây mỗi ngày. Vào cuối những năm 1990, bằng cách quan sát các vụ nổ sao ở xa, nhân loại đã khám phá ra một sự thật đáng kinh ngạc. Vũ trụ không chỉ đang giãn nở, mà nó còn đang giãn nở ngày càng nhanh hơn. Một lực vô hình nào đó đang chống lại lực hấp dẫn, khiến các thiên hà bay xa nhau với tốc độ chóng mặt và ngày càng tăng. Năng lượng tối chính là động cơ thúc đẩy sự tăng tốc này. Hãy tưởng tượng bạn đang ở trên một con tàu giữa đại dương, được bao quanh bởi nhiều con tàu khác. Tất cả đều sáng đèn rực rỡ. Nếu năng lượng tối tiếp tục hoạt động, những con tàu đó sẽ trôi xa bạn nhanh đến mức ánh sáng của chúng, dù đang di chuyển về phía bạn, cũng không bao giờ có thể vượt qua được sự giãn nở của chính không gian. Nó sẽ không bao giờ đến được với bạn. Trong một tương lai rất xa, hàng tỷ năm nữa, mọi thiên hà ngoài dải ngân hà của chúng ta sẽ biến mất hoàn toàn khỏi tầm mắt. Khi đó, bầu trời đêm sẽ trở nên thực sự cô đơn và tăm tối hơn bao giờ hết. Năng lượng tối đóng vai trò như một lời nhắc nhở về giới hạn của những gì chúng ta có thể biết. Nó tạo ra một khoảng cách vĩnh viễn, ngày càng lớn, biến những vùng không gian rực rỡ thành bóng tối không thể xuyên thấu. Tuy nhiên, thay vì sợ hãi trước sự cô độc của tương lai này, hãy để ý nghĩ này giúp bạn trân trọng bầu trời đêm mà chúng ta đang có. Chúng ta đang sống trong một kỷ nguyên vàng của thiên văn học, một thời đại mà các thiên hà vẫn còn đủ gần để chúng ta nhìn thấy và học hỏi từ chúng. Bóng tối được tạo ra bởi năng lượng tối không phải là một sự trừng phạt, mà là một phần cần thiết của kết cấu vũ trụ. Nó ngăn vũ trụ sụp đổ dưới sức nặng của chính nó, đồng thời tạo ra không gian rộng lớn để chính thời gian có thể trôi đi. Hãy để tâm trí bạn trôi vào sự bao la đó và cảm nhận sự nhẹ nhàng đến từ việc biết rằng ngay cả những lực mạnh mẽ nhất cũng đang góp phần tạo nên sự tĩnh lặng của màn đêm. Nếu năng lượng tối là sức mạnh đẩy không gian ra xa, thì một thực thể khác lại đóng vai trò là chất keo thầm lặng, gắn kết mọi thứ lại với nhau. Đây là vật chất tối. Đó là một trong những bí ẩn lớn nhất trong khoa học hiện đại, bởi vì nó không phát ra ánh sáng, không phản xạ ánh sáng và không hấp thụ ánh sáng. Nó hoàn toàn vô hình trước mọi kính thiên văn hiện đại. Dù là Hubble hay James Webb, chúng ta biết vật chất tối tồn tại không phải vì chúng ta có thể nhìn thấy nó, mà vì chúng ta có thể thấy tác động của nó lên mọi thứ khác. Khi quan sát các thiên hà, các nhà khoa học nhận thấy rằng các ngôi sao ở rìa ngoài cũng đang quay quá nhanh hơn nhiều so với những gì có thể giải thích được bằng lượng vật chất nhìn thấy được. Phải có một khối lượng khổng lồ, vô hình nào đó, gấp khoảng 5 lần toàn bộ vật chất thông thường cộng lại, đang ẩn mình trong bóng tối, cung cấp thêm lực hấp dẫn cần thiết để giữ các thiên hà lại với nhau. Vật chất tối có ở khắp mọi nơi, bao quanh các thiên hà như một vầng hào quang vô hình. Nó là một phần của câu trả lời cho câu hỏi tại sao bầu trời đêm lại tối như vậy. Đại đa số thứ tạo nên vũ trụ của chúng ta đơn giản là không tương tác với ánh sáng. Bóng tối mà bạn thấy giữa các vì sao có thể chứa đầy một mạng lưới rối rắm của các sợi vật chất tối, tạo thành một cấu trúc vũ trụ vĩ đại, nâng đỡ toàn bộ vũ trụ. Hãy tưởng tượng bạn đang đi dạo Trong một khu vườn vào ban đêm, bạn không thể nhìn thấy gió, nhưng bạn có thể thấy cành cây xao động. Vật chất tối cũng giống như cơn gió vũ trụ đó, thầm lặng nhưng đầy quyền năng. Nó nhắc nhở chúng ta rằng những điều quan trọng nhất thường là những thứ vô hình đối với mắt thường. Bóng tối không phải là sự trống rỗng của vật chất, mà là sự hiện diện của một loại vật chất tinh vi và cơ bản hơn. Sự tồn tại của vật chất tối mang lại một cảm giác ổn định và bảo vệ. Mặc dù chúng ta không thể nhìn thấy nó vẫn ở đó, giữ cho thiên hà Milky Way của chúng ta lại với nhau, giữ cho trái đất ổn định trên quỹ đạo quanh mặt trời. Bóng tối bao quanh bạn lúc này là một ngôi nhà an toàn, được xây dựng từ chất vô hình này. Hãy để sự hiện diện thầm lặng của vật chất tối vỗ về bạn và cho phép bản thân cảm nhận được sự nâng đỡ bởi trật tự rộng lớn, sâu sắc này của vũ trụ. Mọi khoảng không tăm tối đều có ý nghĩa, mọi thứ vô hình đều có giá trị. Khi bạn kết thúc những suy ngẫm này về các thế lực tối của vũ trụ, hãy cảm thấy thư thái vì biết rằng bạn là một phần của thiết kế hoàn hảo này. Bóng tối không còn là một bí ẩn đáng sợ, mà là một người bạn đồng hành thầm lặng, dẫn lối bạn đến một trạng thái nghỉ ngơi tuyệt đối. Trong hành trình khám phá màn đêm của chúng ta thường nói về tốc độ ánh sáng như một biểu tượng tối thường của sự nhanh nhẹn 300.000 km mỗi giây. Để dễ hình dung, nếu bạn có thể di chuyển với tốc độ đó, bạn có thể đi vòng quanh trái đất 7 lần rưỡi trong một cái chớp mắt. Tuy nhiên, một cách nghịch lý, chính tốc độ đáng kinh ngạc này lại là một trong những lý do khiến vũ trụ trông thật tĩnh lặng và tăm tối. Trên quy mô vũ trụ, tốc độ ánh sáng thực ra khá chậm. Khoảng cách giữa các thiên thể lớn đến mức ánh sáng trở nên giống như một người đưa tin đi bộ qua một lục địa rộng lớn. Khi bạn nhìn vào một ngôi sao ở phía xa của dải ngân hà, cách chúng ta khoảng 100.000 năm ánh sáng, bạn đang nhìn thấy nó như nó đã từng tồn tại khi con người hiện đại lần đầu tiên đặt những bước chân đầu tiên trên hành tinh này. Giới hạn tốc độ này có một hệ quả không thể tránh khỏi đối với màu sắc của bầu trời của chúng ta, bởi vì ánh sáng không thể ở khắp mọi nơi cùng một lúc. Luôn có những khoảng trống về thời gian. Vô số ngôi sao đã được sinh ra ở những nơi xa xôi, nhưng vì tốc độ ánh sáng là hữu hạn, tin tức về sự tồn tại của chúng vẫn đang di chuyển trong không gian và chưa có thời gian để đến được mắt chúng ta. Bóng tối mà bạn thấy giữa các vì sao đơn giản là khoảng thời gian chờ đợi để thông tin đó đến nơi. Imagine the universe is a vast stage, and every star is an actor holding a candle. Because this stage is so enormous and the speed of light is finite, when an actor lights a candle far away, it takes a very long time for the audience to see it. If that stage were to expand forever, we would see immense regions of darkness where the actors have not yet had time to bring their light to the audience's seats. The finite speed of light gives us an unexpected gift, the privacy of time. It prevents all the energy in the universe from compressing into one place and incinerating everything. It creates a slow rhythm, allowing us to observe the universe in different layers, from different eras. As you lie in the darkness, feel the leisurely pace of light. There is no need to rush. Darkness is the patience of space, a place that holds the images that are still on their way to us. While the previous chapters discussed light being stretched or not having arrived yet, in this chapter, we will confront the true enemies of light: black holes. These are regions of space where matter is compressed so tightly that it creates a terrifying gravitational force, so strong that nothing, not even light, can escape once it has crossed the event horizon. Black holes are like punctures in the curtain of light of the universe. They emit no light whatsoever, so they appear as points of absolute black, blacker than the black of empty space itself. At the center of most galaxies, including our own Milky Way, there is a supermassive black hole. They exist in silence, swallowing any light that falls within their grasp and never returning it. The existence of black holes helps explain why parts of the universe are bottomless voids. They are the end points of light, where the most brilliant information is imprisoned forever. However, do not feel frightened by this. black holes act as giant anchors, giving galaxies a stable structure around which stars can orbit and shine. The darkness of a black hole is a special kind of darkness. It represents the absolute power of gravity. It reminds us that in the universe, there are always limits that light cannot overcome, places where secrets are kept in the most complete way. This blackness creates a necessary balance, a counterweight to the brilliance of the stars. Imagine your mind now letting go of all the bright lights of thought, sinking into a region of absolute stillness, like the inside of a gentle black hole. There is no sound, no image, only the deepest peace. All anxieties, all the harsh lights of a long day are pulled into this space and disappear, leaving you with a pure and relieving emptiness. As we conclude this chapter, we realize that darkness is not merely the absence of light, but sometimes it is the result of a great power protecting the order of the universe. Those abysses keep space from falling into chaos and create a mysterious depth for the night sky. Let this silence guide you deeper into sleep, where even the last rays of light give way to complete rest. When we lie on the ground and look up, we often assume that the black of night is an unchanging constant of the universe. But let your mind journey further, leaving Earth to set foot on other worlds. There, would the night be as pitch black as we see it? The answer depends on that planet's location in the galaxy and the nature of its surrounding atmosphere. Imagine you are standing on a planet deep in the core of a globular cluster, a place where millions of stars are densely packed into a relatively small space. There, the distance between suns is measured in light months instead of light years. In the sky of that planet, night never truly exists. Instead of a deep black, the sky would blaze with thousands of stars as large as moons, turning the night into a brilliant and eternal twilight. It is a world without darkness, but also a world whose inhabitants would never be able to see the rest of the vast universe. Conversely, if you were standing on a lone planet, drifting through intergalactic space, millions of light years from the nearest galaxy, you would see a night of absolute blackness. In that sky, there would not be a single speck of light, not a single star to guide the way. It is the darkness of complete emptiness, where the light from distant cosmic islands is just a faint smudge that the naked eye cannot perceive. The atmosphere also plays a crucial role. On Earth, the layer of air helps scatter the little remaining light, creating a soft, gentle night. But on the Moon, where there is no atmosphere, the sky is always pitch black, even when the sun is shining brightly overhead. The contrast between the harsh white light and the deep black shadows creates a scene of eerie silence. Imagining the sky on other worlds helps us realize that the black we see every night is a privilege of our geographical location. We are situated in the suburbs of the Milky Way, a position just right to see the brilliance of the stars, but also far enough to have a quiet night. This darkness is not monotony, but a lens that allows us to see into the very depths of space. Feel the good fortune of being able to gaze at the sky from right where you are lying. The blackness is not so dazzling that it keeps you awake, nor so empty that it makes you feel lonely. It is a perfect balance, a gift from the random yet incredibly magical arrangement of the universe for our blue planet. Why do we need darkness? After journeying through theories of physics and astronomy, let's return to ourselves, to the biological rhythm flowing in your veins. The darkness of the universe is not just a scientific phenomenon. It is a prerequisite for the existence and development of life on Earth. If Olbers Paradox didn't exist, meaning if the night sky were as bright as day, life would never have had the chance to sprout. The Earth's temperature would rise to terrifying levels. All oceans would evaporate, and not a single cell could withstand the immense energy radiation pouring down from every direction. Darkness is a great heat sink, allowing our planet to release excess energy into cold space, keeping the temperature moderate. Inside your body, darkness is the signal to initiate the miraculous processes of recovery. When the light fades, the brain begins to secrete melatonin, a sleep hormone that helps heal damage, consolidate memories, and regenerate energy for the new day. The vast night outside is like a gentle reminder from the universe. It's time to rest. Darkness is also a teacher of humility. In the daylight, we see ourselves as the center. We see our work, our worries, and the small world around us. But when night falls, the universe truly reveals itself. Darkness opens up a vista, billions and billions of kilometers wide, showing us our true place among the stars. It teaches us to dream, to be curious, and to be in awe of the beauty of infinity. Every living creature, from flowers that close their petals at night to nocturnal predators, depends on the rhythm of light and dark. Darkness is not something scary or negative. It is one half of life, the necessary silence that gives light its meaning. Without the pitch-black darkness of the universe, we would never know the beauty of a shooting star or the mystery of the Milky Way. Right now, as you lie enveloped by the night, feel this deep connection. The darkness is working for you. It is soothing your tired eyes, slowing your heart rate, and guiding your mind to its most peaceful place. You don't have to do anything, just let the night fulfill its mission. We are nearing the end of this journey. All the mysteries of the blackness of the universe have gradually been unveiled, from the expansion of space to the limits of time and the speed of light. But above all, darkness exists so that we can rest. Let these thoughts dissolve into the void, preparing for the final chapter where we will truly return to absolute silence. Our journey through 20 chapters about the mysterious night has now reached its final pages. Together, we have traveled through 13.8 billion years of history, from the brilliant moment of the Big Bang to the quiet expansion of space today. We have understood that the blackness of the universe is not a meaningless void, but a symphony of many factors. The finiteness of time, the limit of the speed of light, the stretching of wavelengths, and the presence of invisible forces like dark matter and dark energy. But beyond all the trillions of kilometers and the dry theories of physics, darkness is a state of the soul. As you lie here, amidst the stillness of the deep night, you will realize that darkness is the very shape of peace. In the daylight, our minds are often distracted by countless sights, by bustling sounds, and the worries of daily life. Only when night falls, when the universe unfurls its deep black carpet, do we truly have the chance to return to ourselves. Imagine the darkness out there, slowly flowing into the room, as gentle as cool water, soothing every bit of tension from your body. You are no longer a separate individual, trying to understand the universe. You are a part of that universe. The atoms that make up your body, from the iron in your blood to the calcium in your bones, were all forged in the cores of stars that died billions of years ago. You are a product of light, but you are being nurtured by the darkness. The darkness of the cosmos teaches us to let go. It shows that even the brightest stars must eventually rest, that even the greatest galaxies are moving away to create space for stillness. So, allow yourself to release the unfinished thoughts of today. All the knowledge, all the questions about Olbers Paradox or distant black holes are now just tiny ripples on the surface of your mind, which is slowly becoming still. Feel the gentle weight on your eyelids. Feel the absolute tranquility spreading with each breath. The pitch-black universe out there is protecting your sleep, keeping the world in a perfect balance so that the sun can begin a new cycle tomorrow. The darkness never ends. It just temporarily makes way for the light, just as sleep is a preparation for an energetic new beginning. Thank you for joining me on this long journey through the space of knowledge before sleep. I hope that these stories of the stars and the night have brought you not only new insights, but also a profound sense of peace. You are safe, You are held, and you are merging with the great rhythm of the universe. Now, let all the words fade. Let all the images dissolve into the gentle blackness of the sky. There is no more distance, no more time, only absolute silence and your gentle breath. I wish you a very deep, sound sleep and beautiful dreams in the heart of the vast cosmos.